In this video, we're going to practice measuring volume. So remember, volume is measuring a three-dimensional space. Okay, and we live in a three-dimensional world, and one way to think about a three-dimensional space is think of this as the corner of a room. Okay. So your room, you can walk this way. There's probably a wall here, so you couldn't walk this way, but this is one dimension you can move in. You could walk in this dimension, or you can go up and down if you jump or sink into the floor. Okay, so this is the third dimension. Okay, so notice you can see those pieces in this figure, and hopefully with the shading you can see that this is representing a three-dimensional object, not just a flat two-dimensional object. Even though it's on a two-dimensional piece of paper, you could imagine the depth of this figure. So let's go ahead and read the question. The figure below is the front view of a three-dimensional object made up of stacked cubes. How many cubes make up the volume of this figure, including the ones we cannot see? Okay, so when you look at this, you can imagine that underneath this square, or cube, sorry, there's another cube. Underneath this cube, there's another cube. Underneath this cube, there's going to be a cube that lines up with these two, and another cube all the way on the bottom. Okay, so when we're measuring volume, we could think of counting cubes. Okay, now I'm going to kind of draw a picture of each of these layers. I'm not going to do the best job because it's hard to draw in three dimensions, and I am not an artist. But we have, let's label them, 1, 2, 3. So there are 3 that are in the bottom row, and behind them there's 2 more. There's one more right here, there's another one under this one, and then there's another one under this one and this one. Okay, so we counted the 1, 2, 3. Now there's also a 4, 5, and a 6. So I'm just going to draw, there's 4 down there, 5 is behind this one, and there's a 6 all the way behind this one and down. Okay, so that's the first row of cubes. Now if we look at the second row, there's 2 we can see, so let's label them 7 and 8. And now there's 1 underneath this cube that we can't see. We'll label that one 9, and this one on top is 10. Okay, so the volume of this figure is 9 cubes. And we weren't told the length of the cubes. We typically measure volume in cubic inches. So we'd, for here, since we don't know what this length is, we'll just say 9 cubes. Okay, let's look at the next one. Determine the volume of the toy staircase shown by imagining that it is filled with centimeter cubes. Okay, so now we're told that they're centimeters, so let's look at what we have here. Okay, so again it's a staircase, and notice here we could see that there's layers underneath it. So there's more to this diagram than we can see from the front. Okay, and we're told that this length is 10 centimeters, the height of a stair is 1 centimeter, and it's also 1 centimeter deep going into the square, or into the stair, excuse me. Okay, so let's imagine filling it with centimeter cubes. Okay, well this is 10, so if I went straight across, there'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cubes here. Okay, and again, pretend they're the perfect cube size, even though I'm not a good drawer. Okay, so each one of these would be 10 cubes. Now notice, underneath here, we also have this same type of figure, we just can't see it, and we do here as well. So the bottom stair has 1, 2, 3 copies. So 1, 2, 3, 3 copies of 10 cubic centimeters, which we'll write as 10 centimeters with a cube sign. Okay. Now let's look at the second row. We'll notice this width is the same. It's another 10. We could do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and that may be a little bit off, but let's just number them. 5, 6, 7, 8. 1 extra. 9, 10. And I beg you to use your imagination and pretend those are the same size. Okay, so that's another 10 cubic centimeters, and notice there are 2 copies because there's one of these behind the middle step. So the middle stair has 2 copies of 10 centimeters cubed. Okay, and we can see the top stair, it just has 1 copy and it's equivalent to one of these stairs. So the top stair is 1 copy of 10 cubic centimeters or centimeter cubed. Okay, so these units, you can think of sugar cubes. There are little cubes. Each length is a centimeter. This length, this length, this length, even though it doesn't look like it in my picture. Okay, and this is how many we have in total. So the bottom stair is 3 10 centimeters cubed, plus the middle stair, which is 2 copies of 10 centimeter cubed, plus the top stair, which is just 1. Okay, so 3 10 centimeter cubes will be 30 centimeter cubes. 2 copies of 10 centimeter cubes will be 20 centimeters cubed, and 1 copy is 10. And now since they're all the same unit, we can add them up. 30 plus 20 plus 10 is 60 centimeters cubed. Okay. What units would be appropriate to use to measure the following? Okay. So again, with these problems, you might even want to do a little bit of internet searching to help you. I'm going to give you some ideas of what I think of these values that maybe you'll be able to connect with. But to make sense of these ideas, you really need to have some sort of reference. Okay. So first, let's look at this sheet. And these are a bunch of charts from your media lesson packet. And here are some measures of units of volume and capacity. So we think of capacity as liquid volume. Okay. So one way to think of it is thinking of all of the cubes, okay, and what the length of the cubes are. Okay. So we could connect the idea of inches, feet, and yards like we did before with millimeters, centimeters, meters, kilometers, and miles. Okay. And then we also have these different smaller measures like teaspoons, tablespoons, pints, quarts, gallons that aren't necessarily in cubes. They're typically what we measure liquids with. Okay. So when you think of the amount of water in a bathtub, the first thing I think of is gallons. Okay. But we're going to use cubed measures for all of these as well. So we could say gallons, and then think of, would you measure one dimension? So a bathtub has a length, a width, and a depth. Would you measure it in inches, feet, miles? I'd probably go with feet. It might be a foot deep at most, but the length would probably be at least 1 foot. So we might measure this in cubic feet. Okay. Now the corresponding unit in the metric system, for feet we'd probably use either meters or centimeters. So centimeters are smaller than inches, so I'm going to go with cubic meters of water. Okay. Now let's think about the amount of coffee in a mug. Okay. So when I go to Starbucks, they have different sizes and they're measured in ounces. So that's something you might be able to connect to in terms of our US customary unit. If we were going to measure that in cubes, I'm thinking cubic inches would probably fill this up. So cubic feet would be too big. And a close approximation of inches is centimeters, so we're going to use centimeters cubed as our metric unit. amount of helium in a balloon. Okay, so I'd say I'd probably measure that in inches. You know, they'd be a balloon is maybe a foot in one direction, but probably less than a foot. So I'm thinking cubic inches would be a good measurement, and then our corresponding metric unit would be a cubic centimeter. The amount of fluid in a single tear of joy. Well, that's small, okay? So what I'm thinking of in terms of some of our basic ones, let's go to this chart, okay, is the smallest measure we have in our U.S. customary system is a teaspoon, and I'm thinking a single tear of joy would not fill a teaspoon, but that would probably be our best bet on this list, okay? Otherwise, we could also use cubic inches, and I think the closest one would probably be a cubic millimeter. So this, we may want to go metric to measure this single tear of joy. So what do we say? We could look at a teaspoon, but it would probably be less than 1/1, but we could still measure it that way. Or we could go inches cubed, because that's our smallest unit we have for length in terms of our system, and then metric would be the way to go with cubic millimeters.